With 6 to 4 gigs of VRAM, you should be able to generate quality videos without hitting out of memory issues. If you follow this workflow thoroughly, you should be able to prevent time-consuming and quality issues that you face whilst generating videos like you see on the screen. Now basically, I have 6 different files for you, but each of them are categorized into 2. Now basically, the first 2 files, one is for 30 series plus cards, which is the iterative system, and then the other is for the 20 series cards on the same iterative system. The other 2 are for the non-iterative system, and then the further 2 are I think one is for a loading model and the other is for upscaling. Now basically, I believe that limited hardware should still be able to run a lot of local LLMs and give us the leverage to do whatever we want to do. And so if you like the kind of concept, make sure to smash the like, subscribe, and bell button, most importantly, to get notified, and I'll see you guys on the other side. Let's jump right in. Now, I'm no expert, I'm still experimenting, but when it comes to out of memory issues and VRAM being so slow or sometimes having so many issues, I like to come to my ComfyUI and then I click on the ComfyUI sign. I go ahead and click on settings. Now, if you're a terminal person, you can do exactly the same thing through the terminal. I scroll the way down and click on the server config. I scroll the way down again and find a memory right here, and then I turn on the low VRAM flag. It helps me a lot. What that basically does is that it pushes most of the model, if it can't fit into your VRAM, right into your RAM, and then it keeps things smooth and stable. Now, that is one of the first things I like to do. Imagine you have an empty room and you invite a cleaning crew to work, but they are paid per second while they are working. If you give them a massive job right away, you are waiting for them to both move their mops and cards into the room before they actually start the job. This makes it very hard to tell how long it actually took for them to do the cleaning job. However, to fix this, you give them a small task. This lets them bring their things into the room and then finish that small job quickly fast. After that, any other work you give them will only take the actual time it takes to clean because the equipment is already inside the room. This is the exact reason why I gave you guys the model loader that is down in the description. Basically, we're giving the AI or the load node a very small image to use for our first video generation, and it's also going to have the lowest resolution, lowest length, and has the lowest amount of passes. Basically, I'm going to show you an example. If I click run right now, we're going to wait, and what's going to happen is that on the first run, it's going to load all the models that will be needed, and then after the first run, you're going to realize that it's only going to be doing the job just like I showed you previously. Now you can clearly see that the first generation took about 92 seconds, and then if I run it a second time, you're going to see the difference between the models loading and the actual time it took for this simple job to be done. So let's run it a second time and let me show you what I actually mean. Great, now you can see that 92 seconds and this is 19 seconds. And so that took about 20 seconds just to finish this job. However, then the rest of the time or the rest of the seconds actually went to the models being loaded into your VRAM and RAM the first time. And that is the reason why I wanted us to do it that way. So you're able to tell the actual time that it takes to generate anything that you do the first time or after the first time that you've run anything. Now we're going to be benchmarking your GPU and the VRAM that you have to find one optimal time for you to generate a 1-second video before we proceed. Now basically, remember that there's upscaling. If you saw at the start part of the video, I tried with 720p and it took me about an hour to generate anything, and so that tells you that you can always go lower and upscale. Upscale is pretty fast, or upscaling is pretty fast. And so once again, you can see here that I have 864 times 480. Whenever you change this, you can use photo P or anything to bring your scale down. However, always make sure that it's the same on width and height right here. And all we're looking for now, I've disconnected this length, but we're looking for just a 1-second video at 24 fps, and then our steps are on 4. I want you to play around with the resolution to find a reasonable generation time that you can sit down and say, okay, I'm okay generating a 1-second clip for, let's say, 60 seconds or 72 seconds, and I'm fine with that. And so basically, with the iterative system, for example, I generate the first time with 71 seconds, and the second time it's actually giving me about 63 seconds per a second's generation, which is far better. But as you keep going, you're going to reach a point where your CPU or actually your GPU breaks, and then when it breaks, you're now going to realize that it's giving you worst times about an hour for just 5 seconds. And so that's why I introduced the iterative system, and this iterative system basically just lets you use 2 seconds or 1-second iterations over and over again without overloading your GPU. Also, you need to realize that this very key sampler is one of the things that can keep your model loading and wasting so much time whilst generating. Now, basically, these steps, if you increase them, you're going to wait a little longer. Now, basically, if you saw the starting part of the video, I was using Euler Ancestral, and then I changed to Euler. Now, basically, Euler Ancestral just takes a very long time, but sometimes it can get things accurate. Whilst Euler, I don't know, but there's so many different ones here that you can also try out. All of them are probably going to give you different times. And if you saw in the other part, I showed slow GPU usage or low GPU power. Now basically, I just boosted my GPU very high, and so I'm getting everything that I need to get out of it. Also, one thing that really cut my time in half was really setting my GPU to full throttle. Now, basically, it was 86 seconds the first time I generated post the model loader, and then the next time I boosted everything to 100%, I actually got 46 seconds basically. So that's almost half of the time from 88 or 86 initially. And so basically, if you want anything to be done about that, you can also boost the performance of your GPU. Maybe you can overclock, or you can hit all your fans at max speed. Now here are some examples of some videos I generated, and you can see how Eula is really suffering. Eula Ancestral really does a good job, but Eula is pretty much suffering with this Viking prompt that I gave to it, and you can see that it's basically morphing into something else. And so in the next edition, I'm planning to actually add some end frames to the iterative system, and also add some kind of prompting that will make everything, you know, adhere and move very smoothly and quickly. You can see that over and over again I tried with Eula, and Eula is just basically not being able to get anything done properly. And so I changed the Eula Ancestral, and then you saw that the time really jumped. However, I came down to, let's say, 720p, and then you can see that it looks pretty good. Now, but if you've seen any of the videos that I've shown you on screen, you can tell very well that using this last frame iterative system sometimes can get very, very muddy, where you see the character either changing altogether because I'm using Eula, or even with Eula Ancestral, you might see that the character stays the same, but it gets very, very muddy. Now, here's the thing. Try the highest resolution you can possibly get without losing so much time, and then try the upscaler. The upscaler can only do so much. If you give it, let's say, very, very muddy pictures or very, very muddy stuff to do, it's just going to give you a much, you know, higher resolution muddy stuff to work on. And basically it has a limit to what it can do. And so basically you have to be very careful when it comes to getting these images and stuff like that to do. Now basically the chunking system too, you can go ahead, I don't know how many times I've said basically, but the chunking system here too can also be changed. And one thing that I was talking about was the VA tiled. Now basically, okay, I have to stop saying basically. Now if you look at the VA decode stuff or VA tile decode stuff, it is one of the systems that will help you break down the, how do you even call it? It just breaks it down and makes it very, very simple for the GPU to run stuff. However, I'm just leaving this out because it's not really that much of a difference for me. And so what I've basically done, if you want to understand the workflow, is simple. I basically start with my model. The model is the distilled Q4. I'm just breaking this down for the guys that want to go in technically and try to fix some things even before I get to it in my next video. This is the distilled version. Distilled versions don't need that much passes, and that means that, you know, it's about 12 gigs being loaded into your VRAM and then your RAM. And so if you have more than 12 gigs of VRAM and RAM combined, then you should be good to go. Now, once I have this model gone with a checkpoint, I pass it. If this was a 20 series card plus, I'd have used the Sage, but I'm not using Sage. I'm using the chunking method. Now, I found out that if you're going for something like the linear method and you're not using chunking, it's much faster. However, chunking can reduce the stress on the VRAM. And so I had the chunking down here. And then if you come down, you can see that I use Gemma 3, and that's also about 6 gigs. And so it's also, what's happening is that it's loading the clip 1 and clip 2 into model. When it's done loading the prompt, it just stores a token of them and then it loads them out of your VRAM. And so I'm using Gemma 3 and I'm using the LTX 2.3 22 billion parameter for the clip 2. Now basically when I move on, I just have my prompt here. The prompt is also going to be in it, so don't worry about that. And then I have my VAE, which is also the same thing as the 2.3 that I had here. And then if I come up a little bit, you can see that I have the load image. Now I'm going to have to find a way to actually get you guys to get, you know, the starting frame, the ending frame, or even starting and middle frame. That would be, I think that would be very good, because now I'm thinking of merging two different systems. I think I gave you guys the system. However, this system does not have any iterations, and basically I can go for about 4 seconds on 11 gigs of VRAM and have absolutely no issues. It's going to even run faster than running just for a second. However, when it comes to the iteration, I'm trying to merge those 4 seconds. Probably I'll have a middle frame and then an ending frame to make sure that it does not get blurry, because the main reason why it's getting blurry is because it has to picture what the ending frame is going to look like if you do not guide it. And so that's how I'm going to have to come up with a way to find it. If you're down in the description or you're down in the comment section and you're technical enough, you can hit me up. I think I'll put a new Discord down in the description as well. If you want to join, you can let me know once after that. Now also, I think that I'll also be working on the K sampler. I think that people have found much smarter ways to use these K samplers to reduce the VRAM and reduce the time that it takes, because I found out, I think I've only tried 2 so far, Eula Ancestral and then Eula. I've not tried anything else. I've also not even tried any other video model apart from this. And so also I'm thinking of trying some chatbots and stuff like that. So let me know down. I think I'll leave a question here. I should leave a question down in the video below if you guys would want me to either do, let's say, chatbots and LLMs and stuff like that, or if you want us to go more into videos or pictures or whatever you'd want. But I know there's some of you down in the comment section that are going to be asking, is this going to work on a 30 series card, a 40 series card on this specific rig? It's going to work if you have 4 gigs of VRAM and just 8 gigs of just normal RAM, as long as you're following the procedure of doing the iterative system and testing and benchmarking and finding out what your system can handle max. Now, I thought of breaking down that video very well with an analogy, and I think Gemini actually made one for me. Now, imagine someone that is holding a box, which is your GPU. It's holding a box and it has to cross a room and put that box on a table. Now, if you give it a very heavy box, it's going to take a long time. But if you give it smaller boxes to carry, for example, one video is 1 second, the next one is 1 second, it can carry 4 of them and take them across the room and come back and do that same heavy lifting very quickly. And so I found out that you have to just benchmark your GPU and find out the best it can do, and then try to integrate the iterative system. Now, I don't want the iterative system to be the one where you click and then you come back and give it the next frame. That's going to be stressful. Imagine you want a 1-minute video and you have to keep coming back to the load image and changing it whenever you want. And so basically, I'm just going to be making some heavy changes in the next video. If you're interested in this kind of content, make sure to smash the like, subscribe, and bell button, most importantly to get notified when I drop new fresh videos. And with that said, come join our Discord and let's communicate and find a way to get this thing to work for people on low hardware or hardware that is basically your personal hardware. With that said, it's your boy GD Code, and I'll see you guys in my next video. Peace out.